can come in. Okay, first thing is we have some problems graphing this. So let's graph this with our graphing calculator. You have to be really careful. Okay, guys, I'm going to graph this. I'm going to show you what you came up with. At least looking around and what I've seen people doing. Yes. Yes. Okay, so I'm going to clear all this out, and we're going to go into y equals, and we've got to make sure we enter this correctly. And this is 20 divided by parentheses 1 plus x squared. And you have to go back. Okay, and the other one was y equal to 2, correct? Okay, so we're going to graph that. We will zoom it in a standard window, which is probably what you did. And you get this. What's the function again? It's 20 over 1 plus x squared, right, Cole? Is this function, does this have a vertical asymptote? Okay, Sarah, Karen? Focus. Does that have a vertical asymptote? No. When would you have a vertical asymptote? When this denominator is equal to what? 0. Guess what? It's not 0. So your calculator is not really lying to you, but like I said to the other class, it's like looking out the window at Pikes Peak, and I'm not going to see the top of the mountain unless I go outside and look at it. You're cut off with your window. You have to change your window. When x is 0, what's the y value? 20. So those of you who had this picture, you're done before you even start, because everything's going to be wrong. So I have to go in here, and if I don't know, I'm going to go second table set, and I'm going to start it at 0, and we'll count by ones, and then we'll look at the table just to see how big the y values get. If I don't know, especially if it's a complicated function, this one's not bad. But I can see that it gets up to 20, and it doesn't look like it gets any higher. So what I'm going to do is I'm going to zoom it, and I'm going to zoom it decimal, because I'm going to get better x values. I'm not going to get good y values. Like, that even looks worse, doesn't it? Okay, and I remember this problem in the comments on the AP exam. It seems to be kind of stuck. Let's press on and see if I can get it unstuck. You know, if your calculator gets stuck, just press your on key. It'll interrupt the loop. But I'm going to change the window on the y's to go up to 20. Oops, window. How about 21? Then I'll get a much better picture. There it is. And it says, you have to learn to read. It's clearly bounded by above by this curve. So that means above the region is the curve, and it's bounded below by y equals 2. So let me take that picture. That's what it says. Read the problem a couple times when you're doing this. Okay, and it says bounded above by this graph and below by that. Now, the problem is you can't do underneath this line because this never hits the x-axis. So that's a problem. It's called an improper integral. But that's not what we're going to have anyway. So the region we're going to have here is this. And then I went through in the other class exactly what's happening based on some of the questions I'm hearing. Well, I really wanted to grab that one. I hate that one that doesn't do that. Okay. I will have to find that. But when I'm looking at this, how do I find the area? I could find the area of my hand. I couldn't really do this. Oh, it's not going to let me do this very well. You know, I could do this, and I don't have a measuring tool. Okay. I don't have a good measuring tool, but I could cut in little horizontal vertical rectangles and put them in there. Well, I'm going to do that here. I'm going to put a whole bunch of rectangles in there. Remember when we did Riemann sums? Well, that's all this is. I'm going to find the areas of all these rectangles and add them up. So what's the area for one rectangle? It's the base times the height. So it's going to be base, is that delta x or is that delta y? Well, good job. And it's times the y value. So the first rectangle is f of x1. Plus, then I have the second rectangle. I'm going to leave all my bases the same. Are you okay with that? Yeah. Okay. Okay, Carolyn? All these bases are the same. I want you to see why this works. If we see why it works, maybe we'll figure this out. And what I can do is n times. Okay, and we're going to write this in sigma notation. And if you're going to take BC Calc, get used to it because I'm going to do a lot of this. This is just a counter. It's f of x sub I. Well, I is going to start with 1, then go to 2, 3, and all the way up to n. I equals 1 to n, and this is delta x. When I look at this, I should see a rectangle. I see a rectangle. There's the base of my rectangle, and there's the height of my rectangle. And how many rectangles are we going to put in there? Infinite number. Limit as n goes to infinity. And Riemann says, another class said, do we really have to write it that way? No, but that's what it is you're doing. You're finding the height for each one, so these change in value. Delta x doesn't change in value. And so we can write this as this integral from a to b of f of x dx. That's a definition. But you know how to find that, because what does that mean? We find the what? Antiderivative evaluated at b, evaluated at a, and that's the fundamental theorem of calculus. Now, why do you believe that the area under the curve is the antiderivative evaluated at the endpoints and then subtracted? Because I told you that. That's right. You should be questioning that. That should bother you. Why would an antiderivative be an area? The derivative makes sense because you're just limiting your slope to be, you're zooming in on your curve. So that makes sense. This doesn't make sense. And maybe after the AP exam I could show you. It's a difficult proof, but it's kind of a nice little proof of how that works out. Well, it's only because I told you. No. But you should be questioning things. You should always be questioning things. Because I do make mistakes. Okay, so all we're going to do is we're going to find a sample rectangle, just one of them, so we can figure out what the base and the height are. So the area for one of these is, well, the base is delta x, as you told me. What's the height? These aren't circles, it's just area. We're doing A. We'll get to the volume in a second. Okay, guys? What's the height then? y1 minus y2. Okay, and what are we going to do with these? We're going to add them all up. So it's y1 minus y2 dx. We'll put it in calculus notation. I did get some calculator notation. You get no credit for that. So make sure you put it in calculus notation. Some of you probably used to... Pardon?
I did like y1.
That's fine, as long as you tell me what y1 is. I'm going to go ahead and put the function in there. You need to say y1 is equal to this function. You let the grader know that that's what you want, and then you can use y1. That's okay. I can just substitute it in. So the area is equal to, and I'm going to do that because then you can kind of see it. There's that function. And by the way, what variable do I want in my problem? Hey, Zach, what variable do I want? X. This tells me I want x's, not y's. These are always opposite. Then I fix the problem. It's 20 over 1 plus x squared. What's y2? Minus 2 dx. And now I've got to figure out what the limits of integration are. And either I could use my calculator, because this is a calculator problem, or if this were not a calculator problem, I would solve this equation. Okay, so now on the exam, it's not going to be a calculator problem. Now, if this is let's pretend it's not a calculator. If you just told me it's 3 without doing anything, they won't give you any credit for it. You have to show your work. But because this is a calculator problem, you could have graphed it and found the points with your calculator. But we're going to go ahead and do this. We'll cross multiply, because it's not that hard. It's 2 plus 2x squared equals 20. And you should be able to solve this equation as fast as I do. 2x squared equals 18. So x squared equals 9, and there are two values that make that true, 3 and negative 3. So that's what we're going to integrate. And Cole asked me, well, couldn't I just integrate from 0 to 3 and then double it? Sure. If you're going to use your calculator, you still could do this without a calculator, but if you use your calculator, it doesn't really help you any.
Why'd you take this?
I didn't,
Why is it hard?
because we're going to integrate from 0 to 3, because it's identical on both sides. Oh, I remember, I don't know if it's this one or another one, I've seen problems where the students only did half of it. They didn't do the other half. This may have been the one, I don't remember. So be careful that you get the whole region there. Okay, that's worth 3 points. Okay? So you get 1 point for finding the 3 and the negative 3, 1 point for finding the integrand. The integrand is this part that's inside the integral. That's the integrand. And then 1 point for the answer. Yes?
You have to show your work for finding like 3 and negative 3, or can you just find it on your calculator?
You can find it on your calculator if it's a calculator problem. If it's not a calculator problem, then you would have to show how you got it. Yeah, you'd be fine. But on the exam this year, this will be a non-calculator problem. Even if you can just look at it and say, this is what it is, you better support your answer. Okay. Now, what we're going to do next, we're going to find the volume of the solid generated when R is rotated about the x-axis. I'm going to clone that. Yeah, well, kind of. And we're going to take this and rotate around the x-axis. And so I'm going to take this one and I'm going to flip it. And you should have a picture. If you don't have a picture, I don't believe you did the problem. Because, of course, this was in your packet. You had the answers to it. Right? So you all should have gotten this. Correct. This is going to rotate around at you. It's like a wedding bell. You remember those little wedding bells that do this? I meant to bring one in. There's a hole in the middle of that. So if I draw a sample slice, and some of you say you can't do that, yes you can. It's just a circle kind of squished. And now you can see that. That's, pardon?
Should we know what's on the left side of the y-axis? Is it just R that can rotate around?
It's this whole region that's being rotated. I don't know if I can draw it any better than that. And so I'm going to get this washer with a hole in it.
I know if it's a washer, like how do you rotate it?
Because it's like taking that apple, taking the apple core, taking the core out, and then slicing it perpendicular to that axis. You've seen the apple slices. They're round and they have holes in the middle. It's like a donut. Right. And just because we rotated, because if we understand why, then this is easy.
Well, it never touches the x-axis on it. You can just assume that's the washer.
No, I have to look at the picture. That's why I said I saw some with the right answers with no pictures. I can't do it without a picture. Okay, so if you didn't have a picture, I was suspicious about this. Okay, now, on your quiz, I saw a lot of this for washers. Even though we had talked about it, I saw that. I also saw a lot of nobody squaring things, too. Is that right? No, because it's the big circle minus the small circle. Remember, it's the area of the base. It's this piece right there. And then it's times delta x. So it's pi, big radius squared minus pi, little radius squared, and is this delta x or delta y? Delta x. It's the x-axis. Quick check. Yes, Ardavan.
It says, find the volume of the solid generated when R is rotated on the x-axis.
I don't have a model, I wish.
We're finding that for the circles, the washers, between what it gives us first.
Between negative 3 and 3.
So how is that the solid? I feel like I thought we had I get it. You go this way to this way.
Oops. I don't like to type on there.
To
Let me give you a visual on this.
I can't see the big picture. I think I see it now.
Well, you will in about 2 seconds.
I think I get it now.
The cross sections, I can't get that applet to work. I don't know how to do it. Okay. So if we want to change to a cone-shaped hole like that, Oh, that's not the one that gives you the other one. I wanted the other one. But can you kind of see the figure here? It's a little bit darker. It's a cylinder with this V cut out. If you come up here, actually, you can see it
Looks
better.
like one of those candies.
Yeah,
Those squishy.
it's a lifesaver. It's a lifesaver. And I
Really
could,
misleading name for it.
that's a cylinder. Oh, it's a washer. Did you guys ever,
And it's getting
there's an odd
smaller.
shape. There, look at this one.
Is our washer changing?
Yeah, the washer changes. It gets smaller and smaller. The washer there is smaller than that, but it's all taken care of in the calculus. The measurements, because it's finding each individual washer and then finding the volume for each one and adding it up. That's what an integral does. Look at the picture. That's a washer. It's like a lifesaver.
Christian, it's not true. You have to exit habit.
No, we gotta be careful. You gotta be careful with that because it might be, not necessarily, but
But if our picture is symmetrical, how is our washer changing size?
just like I did over here. Where's my little guy? The washer changes size depending on where it is. That's smaller than this one.
So it'll fit over the curve, it changes size. So
To
it'll
fit
over-
within the curves, yes.
Our curves are this way.
It doesn't matter.
Why does it have to change size if you can just stay the same size?
No, it can't.
Because the shape is like
Here's my washer up here
Oh,
with a hole, but now I got a mess. Yeah,
I thought you're just trying to find, the whole time I thought you were finding the area
of this one washer.
in the two cone head things.
No, I'm finding the volume of a washer. Okay, ready? Okay, guys. Okay, guys. Shh. What is the big radius? Now, where do you measure your radius from? This is all geometry. You measure from the axis. This is to this top curve. That's y1. So capital R is the y value there. What's the little radius?
2.
Yep, little r is going to be y2 or 2. So we substitute that in here. Let's factor out the pi. It's y1 squared. I don't care what the function is. That's not important. Minus 2 squared,
Why isn't it y1 plus 2?
because it's the big circle minus the little circle. So it's this big circle here, which would be all of this, and then I have to cut out the middle. You're not adding it, you're cutting it. Okay, shh.
So the big circle only goes from the x-axis to
They all only go from the x-axis to that curve. This case is a line. We'll do a bunch more. Shh. Right. No, but you better have a picture that it's this. And so he's saying, and by the way, you always go to the original function. This is your outer radius. He can't draw the washer very well. And then here's your inner radius. So I'm going to take the circle that goes here and subtract off the cylinder, basically, that's inside there. And this is what, delta x or delta y? Delta x, because we did that. Now I will put in my function, which is 20 over 1 plus x squared. Now, if you have it written here, and you forget to do your squaring here, I believe they'll give you a copy error on that. But you won't get the answer point. I don't think. And then that's dx. And where are the x's going between? Oops. 3 and negative 3. This is all geometry. What's the calculus doing? The integral. Putting the little integral sign in there is the calculus. The rest is geometry. Okay, ready for the last one?
Yeah.
Oh, let's get the answers.
Right.
Matt, what's your question?
419 pi.
No. It's 1,871.190.
Pi.
Oh, yeah, multiply your answer by pi. You can leave your answer in terms of pi, by the way. Perfectly okay. Don't forget the pi. Question.
said the last part where you can all the equations in and the answer, you still get.
That's all you need.
That's all you
Yep.
need.
That's all you need. Okay, ready? I graded the BC one of this version of this, but anyway. Okay. C, and Matt, did you get your question answered back there?
Yes.
Okay. The region is R is the base of a solid. Now this one's tough for me to draw. Okay, so let me draw R again. What, do I have any? And that's the base of my solid, and these things are going to come out at you, assuming I can find any. They are protractors. I'll use half a cookie. I don't have any protractors. Thought for sure I had some in here.
Okay, go ahead.
Well, I can't draw it very well. Yeah, but it helps the visual. But I guess I don't have any. Geometry's in here, I don't know what happened to them. Okay, guys. Shh. Guys, we're getting ready for a test and the AP exam. Okay, that's a protractor. It's coming out at you. Protractor is half of a circle, right? Okay, I can't draw it very well. Okay, if I try to draw it in 3D, actually, I can't. Except I'm right on that crumb of my board. And so it would look like something like this. And then the protractors would be these little circles. And then they're going to get smaller again. It's almost going to look like a tunnel. But I don't care. I just know the cross-section is a semicircle. So what's the volume for this little protractor? 1/2 pi
1/2 pi r squared.
r squared. Now they're perpendicular to the x-axis. Delta x or delta y? Delta x. Okay. Be careful. Is this the radius? No. That's the diameter. This is the diameter. I want the radius. So the diameter is equal to twice the radius. And how do you find the diameter?
1/2 r. No, 2r.
It's this y value minus that y value. So it's y1 minus y2. So r is equal to 1/2 of y1. What's y2? Because that's easy. 2. And then we still have issues putting this into the calculator, I found out. So that the volume, pardon? This is the diameter, is this length. It's the diameter of my protractor. So this length of this segment is y1 minus y2.
And you always call the higher point y1.
Right, because I want the distance, I want it to be positive, right? Because distance is positive. Question, Christian? Did you get it figured out? 1/2 pi. Okay, put your little integral sign in there, and it's going to be 1/2. What's y1? 20 over 1 plus x squared. If I've defined it, you can just leave it like this. Minus 2, and then what do I have to do with this? Square. Do I have to square the 1/2? Yes.
Why do you have 1/2?
Because the diameter is y1 minus y2, but the radius is half of that. This figure, and I've seen this on the exam, where you got to get the radius, and you have to take half of these y values. I just want the radius. So the diameter is this, so the radius is half of that. And I have to square it, and it's dx. Whoops. Now, I recommend that if you're good at putting things in your calculator, you just put this in your calculator. By the way, what are the x's going to be between? -3 and 3. Because if you try to square that, well, you can, but I've seen people say that that's 1/4 pi when they pull the half out, but it's not. The half is squared. So if I pull a half squared out of the integral, what have I got? I got 1/4, so that gives me pi over 8. It doesn't matter. This is where you're going to get your point, and the final answer point will be your calculator. So it's 20 over 1 plus x squared minus 2 quantity squared dx. Just depends on you and what you want to do. But if you simplify it wrong, you will get the wrong answer. Matt?
My calculator, if I put in that going deep, and it's like 5 seconds, I'll still see it. Like the different answers on this question.
What are you running, Inspire?
Yeah, that's what
Okay, I'd have to look at it.
Wasn't divided rate on title 4.
Because this 1/2 is squared.
Oh,
When you have the cross sections, how do you figure out what shape it is? Like, how
I told you it was a semicircle.
Right answer.
What is the final answer? There it is, 174 point. Now, 268, you only need 3 plus places. And last class they said, well, there's a 5 there, so we should round it up. Well, that's not the way they did it in the old days. In my day and age, if this was a 5, we would look to the number just to the right of it, and we say, well, if it's even, we round up. If it's odd, we round down. And then they decided to get rid of that, so you just always round up. It was complicated. Yeah, I think that's how we did, was even odd. Well, that equaled it out better. Of course, the government always rounds up, unless they're giving you a refund. They probably round down, but what happens to all those half pennies? That was in that Superman movie. Superman 3, I believe. Okay,